Kia ora koutou, Reese from QuickSense here, and today we're looking at simultaneous equations. Now there are two ways to do simultaneous equations. You can use the substitution method or the elimination method. The elimination method is what I'm going to do in this lesson, and I'm going to do it because the coefficients are the same. Right? If the coefficients are the same, that means I can eliminate them either by adding or subtracting. So looking here, I can either, right, I've got this form, so ax plus by equals c, and then dx ey equals f. And I'm looking down here because I'm wanting to get rid of one of these variables, right? I can only solve this if there's something by itself. So what I do is I can either add or subtract them. So either a plus d equals 0 or a minus d equals 0. So in this instance, 1 minus 1 is going to equal 0. Equally, negative 1 plus 1 equals 0. So I'm going to add them together and eliminate y. So what does that look like? I'm adding them together, and I'm going to use these square brackets here. The reason I prefer adding is that when you're subtracting negative numbers, it can get a little bit messy, and you're going to tend to make mistakes that way. So 1 plus 1 is 2 lots of x, 0y, and then 34. So that means x is equal to 17. If x equals 17, then I can substitute it. All right, so I'm just gonna move this to the left now. If let's go sub x equals 17 into x minus y equals 6. So 17 minus y equals 6. 17 minus 6 equals y. So the values of x and y, x is equal to 17, y is equal to 11. Now in the previous lesson, the coefficients of my first and second simultaneous equation, or my first and second equations, were the same. So it was easy enough to just add and subtract. But in this situation, I have to make them the same. So I have to scale them up to make them the same. I'm finding common multiples. It's easier if it's lowest common multiple, but it can be any common multiple. So looking at this, probably the easiest one is going to be the one that's going to require the least amount of work, is scaling these up to make them the same. All right, so let's call this equation 1, this equation 2, and I'm going to scale them up so that it is 6y and negative 6y. So how do I do that? Well, I have to times 1 by 3, which gives me negative 12, x plus 6y, 24 times 3, 72. And then number 2, well, I times that by 2. So 10x minus 6y minus 66. And again, because these are now, right, eliminatable, I can go ahead and just do just that. So 2 plus 1, right, I get 10x minus 6y plus minus 12, well, that's negative 2x. That cancels out. Negative 66 plus 12, well, the difference there is 6, so I end up with plus 6. X here is equal to 6 divided by negative 2, negative 3. Now what I'm going to do is substitute sub x equals negative 3 into, let's just put it into 1. So negative 4 times negative 3 plus 2y is 24. 12 plus 2y 24. Y equals 6. So, values of x and y. X is equal to -3. Y is equal to 6.